Welcome to section 9.4, where we'll be solving algebra word problems with strip diagrams along with algebra. Pause the videos often, complete the problems with me, and all the you tries on your own. Pause before you see the solutions. These are the topics, the objectives, the standards, vocabulary, and concepts. We're going to be drawing strip diagrams. Sometimes they're called tape diagrams, and we're going to connect them also to the standard algebraic approach. So often a strip diagram can even help us formulate a word problem algebraically with an equation, and so they can be pretty helpful as well as making sense of the steps. So let's see how a strip diagram can help us solve this word problem. So we've got a payment plan problem. The Browns are buying a TV that costs $1,300. After they make 4 equal payments, they still owe $400 on the TV. How much was each payment? All right, so the strip represents the whole thing here. So we are going to say, all right, they made 4 equal payments. So 1, 2, 3, 4. So these are supposed to be equal. Use your imagination there. And the whole TV costs $1,300. And so this whole thing costs $1,300, and they still owe $400. How much was each payment? So they want to know how much was each of these 4 little payments. So when we look at this as a strip diagram, we can say, okay, well, we've got 4 parts of this, 4 equal parts. We've got these 4 parts are equal to 1,300 minus 400, right? These 4 pieces are the whole thing, 1,300 minus 400. So that's $900. Well, that means one part would be 900 divided by 4, right? Because if we divide it by 4, which is equal to 225. So that means each payment was 225. So again, we can look at that with the strip diagram, and we can see that here. Well, let's keep going. Let's look at this another way. So the Browns are still buying the same TV. We want to use algebraic equations, but use the strip diagram to support us. So we've got 1, 2, 3, 4. We know that that's $400, and we know the whole thing is $1,300. So, well, if we're using algebra, we can use a variable. We can let x equal the number of dollars in one payment. So that means these are X dollars, right? X, 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 X. So then we could actually write an equation. We could say, okay, there's 4 X's plus $400 equals the total of 1,300. And then we could solve it. Subtract 400 on both sides. So we get 4X equals 900. We could divide by 4 on both sides, and we get X equals 225. So each payment is $225. You can see that over here. There we go. All right, let's keep looking at this. So if we were just to use algebra alone, we're not going to use any strip diagram. So now let's let X equal the number of dollars in one payment. So we know that there are 4 payments. They make 4 payments. So that would be 4x. And then after the 4 payments, they still owe, right? After the 4 payments, they owe 1,300 minus the 4x, which they know is 400. So we would just solve that by 1,300 minus the 4x. So after the 4 payments, they still owe $400. So we could subtract 1,300 on both sides. We get negative 4x is equal to negative 900. Don't drop the negative here. And we end up with x equals 225. So again, we don't need the strip diagrams, but they may have been helpful when we're looking at this problem in different ways. So when we put it all together, and you can take a peek at this in your textbook, we can see that there are lots of different ways to look at this, but that the strip diagram is actually very, very helpful. So let's do a new problem. Solve this problem in 2 ways, with the aid of a diagram and with algebraic equations. So we'll just kind of split this up here. So let's use, over here, we'll just say the strip only, and then here we'll do the strip with algebra. All right. So altogether, Ron and Hermione have 70 ragworts. Hermione has 6 more than Ron. How many do they each have? All right, so with the strip diagram, we have Ron and Hermione. Now, Hermione has 6 more than Ron. So if this is Ron's strip, Hermione has the exact same amount, but 6 more. And altogether, they have 70. So how many do they each have? So we know that these 2 parts are the same. So these 2 parts are the same, and they're equal to the total minus 6, right? 70 minus 6, which is 64. So then 1 part is 64 divided by 2, 32. So that means this is 32 and this is 32, which means Ron has 32 and Hermione has 32 plus 6, or 38. So now, what if we were to use algebra with the strip diagram? So we're going to have the same idea here, and maybe even we make them so they're really, you can really see, right? We know that the total is 70 and 6, but now we're going to use algebra. Instead of saying, hey, this is, we don't know, we know that we could say this is Ron's amount. So then we could say let R equal the number of ragworts that Ron has. So we know if we look at this whole thing together, it's equal to 70. We've got 2 R's and a 6 is equal to 70. So we subtract 6 from both sides. We get 2R equals 64. Divide both sides by 2. We get R equals 32. So that means Ron has 32. And then Hermione, remember, she's got R plus 6. So she's got 32 plus 6, or 38. So you can see how we, and this is just from the textbook to help you out, to visualize it a little bit more, how we can use strip diagrams to help us make sense. Go ahead and give this one a try, press play when you're ready to see the solution. And there you go. So let's look at some tips for strip diagrams here. So they represent quantities like variables and segments on a number line. So it's good to fill them in with what we know or what we don't know. And use length to help you. So notice how when we were doing Ron and Hermione, we kept them the same length. So, and don't worry that like, oh, this is just 2 more. It's just for a general comparison, but try to have things that are bigger, longer, and things that are the same look the same. And finally, sometimes using many drawings can help you, and we'll do some examples of those in a moment, where we see how things change over time as the strip diagram changes over time. So here, Mark has all this money. He spent 1/4 of it, so he lost 1/4, so that's gone. So this is what he's got left, and then he gave half of what he has left, so half of this, and we can show it in that, left to Leela. All right, let's look at this example here. Dante has twice as many jelly beans as Carlos. Natalia has 4 more jelly beans than Carlos and Dante together. Altogether, Dante, Carlos, and Natalia have 58 jelly beans. How many jelly beans does Carlos have? So they want us to solve these in 2 ways and say how they're related. So Dante has twice as many as Carlos. Natalia has 4 more than Carlos and Dante together. So let's write it out. Let's just see what we've got here. Dante, Carlos, and Natalia. So Dante has twice as many of Carlos. So if this was Carlos, Dante would have 2 of those. And Natalia has 4 more beans than Carlos and Dante together. So together, she would have 3 of these plus 4. And all together, they have 58. So how many equal parts of these strips do we have? 1, 2, 3, 4, 5, 6. So we have 6 equal parts is equal to 6 equal parts plus 4 is equal to 58. So just 6 equal parts is equal to 58 minus 4, 54. So if we want 1 equal part, well, that would be 54 divided by 6, which is equal to 9. So who has 1 part? So we could go back here, 9, 9, 9, and we could see what everybody has. So Dante has 18, Carlos has 9, and Natalia, oh, who'd they ask for? How many jelly beans does Carlos have? Oh, there we go. We don't even need to answer all that. Well, what if we were to just use, with the aid of a diagram and with algebraic equations. Well, let's just use algebra. Forget the strip for a moment. So let's let X represent Carlos, because that's what the number of jelly beans Carlos has. So we know that Carlos has X, Dante has twice as many, and Natalia has X plus 2X, what they have, plus 4 more. And all together, they have 58. So let's see what they all have. Carlos plus Dante plus Natalia. So then we would combine like terms. That's 1x and 2x is 3, 4, 6x plus 4 equals 58. Well, then we would just solve it the same way. 6x, ooh, I'm running out of space, divide by 6. X equals 9, so Carlos has 9. And that should say 3, huh? There we go. And then here is it written out, if that's helpful for you. And we'll pause here and continue our final example in our last video on this section.